Today we are going to teach you about linear combination identities of sine and cosine with Hannah, Svetlana, and Gabby. Alright, so first what we're going to do is we're going to use this equation and we're going to plug it into our calculator to graph it. So I plugged it in, I set my window to minimum, I set it to 0, and on x maximum I set it to 450. Usually you set it to 360, but I know this graph will shift, so I set it a little bigger, and I'm going to graph it, and I'm going to use second calc to trace minimum and maximum points to find all the points. So when I graphed it, I found that, and you'll find too, that at 62, it's at there, and then the end point will be at 420. And our period is still 360 because it's a sinusoidal graph. And then using this graph, we can find the equation for cosine. Remember, A cosine for transformations, it's going to be B x minus C plus D. So we know A is 2 because that's our amplitude. So y equals 2 cosine. Our period is still 360, so we know that it hasn't changed with B, so we're going to do x minus 60 because it shifted to the right 60, and we know that D is 0 because that's the middle point. So here's our equation for this graph from here. Started with this equation, and we know it can be written like that. Do we see a correlation between P, Q, and A, between square root of 3, 1, because you know that's a 1, and 2? Well, if you noticed, it's Pythagorean theorem basically. So if we had a right triangle, we had square root of 3, and we had 1, then the hypotenuse would be 2. For an example, square root of 3 squared plus 1 squared is equal to 2 squared. So 3 plus 1 is equal to 4, which is Pythagorean theorem. So we know that A is equal to the square root of P squared plus Q squared using this general equation, these two general equations. Alright, so since we know how to find A, now I'm going to tell you how to find C. Using this equation, or a new example rather, we're gonna graph it, and I typed it into my calculator again. And this time I'm gonna find C, or the transformation, in radians. I set my window from 0 to 420 on X, and I set it to 420 because I know it shifts. And I'm gonna graph it, and then using second calc, I will find the high point over here, and that will give me the transformation. So I graphed it, and I'm going to draw it. Here's one way to find it. D is still 0, it didn't shift up or down. Square root of 6 is our new amplitude, and so we know that when it hits square root of 6, it's at 45 degrees. And then since B didn't change, our period is still the same, so it'll still be 360, so we know that's 405. We're drawing a sinusoidal graph. That will be what our graph looks like. So from graphing it, we know that we shifted 45 degrees, so our equation would be y equals square root of 6 cosine x minus, and since I said we're in radians, it's going to be x minus pi over 4, and that would be our equation from graphing it. Since we know that this is positive, sine is positive, and cosine is positive, we will know that on the unit circle, this triangle will be in the first quadrant. So this is square root of 3, and this is square root of 3, then that will be square root of 6, and we can find from using tangent, opposite, which is square root of 3, over adjacent, which is also square root of 3, where it will shift to. So tangent of 1 will shift, where is it on the unit circle? Of positive 1, it's at pi over 4. So that's how we know where we shifted to. So this is how P, Q, and C relate. So here's P, and here's Q, and since they're both positive, sine and cosine are positive, we have tangent of P over Q is equal to C. Alright, so you have this equation, and I taught you how to find A and how to find C for a new equation. Solve this equation. So I'm going to solve it, and you can check your work with me. So first thing I'm going to do is I'm going to find what quadrant this triangle is going to be in. So wherever sine is negative on the unit circle, this is where sine is negative, and wherever cosine is positive, then that's where we will be. So cosine is positive here on the fourth quadrant in the first, and sine is negative on the third and the fourth. So whichever one matches, that's where your circle will be. So on the fourth quadrant. So this will help us in finding C. So negative square root of 3 over square root of 3 equals to tangent of negative 1. There we go. And we know that that will be on the fourth quadrant. So it'll be 7 pi over 4, and that is C. Alright, so we have C, and then we can find A, which is the P squared plus Q squared, which I know is equal to 6, so A is equal to square root of 6. So I can find that Y equals square root of 6. I know that B didn't change because I can also check it with my calculator. So my new equation will be Y square root of 6 cosine X minus 7 pi over 4, and that's it. Alright, so we have this equation, but since we know tangent of negative 1 right here is at 7 pi over 4, so here's the negative 1. We also know there's a coterminal angle for this. So another equation we can write is y equals square root of 6 cosine x plus pi over 4, because this is actually negative pi over 4, which is also equal to 7 pi over 4 if you're moving around the unit circle. Remember to check with your calculator.
So this equation that we have here is the same as q cosine plus p sine x equals a cosine x minus c. And now we're going to be focusing on different ways to solve for D. So depending on the sign of your sine and cosine, draw your triangle in its appropriate quadrant. In this case, both of these are going to be positive. So we're going to draw our triangle in the first quadrant, and then you can label all parts of it. Here's your angle D. So to find angle D, you can do the sine of D equals B over C, or cosine of D equals A over C, or tangent of D equals B over A. And in the same way, you can do the inverses of all of these to find it. So you can do inverse sine of B over C equals D, and then inverse cosine of A over C equals C, and inverse tangent of B over A equals D.
So in our first example, we're going to be transforming this given equation into the a cosine x minus c form. To start out, we're going to be finding our a. And we know that our a is equal to the square root of the cosine squared plus the sine squared. Now simplify that. The simplified form is 5 root 2. Now we have to find the c. When we know to find the c, we would have to do tangent of the sine over the cosine, which in this case ends up being the tangent of -1. We know that there's two places where we find tangent of -1, but only in one of those places both the sine is negative and the cosine is positive, which is in quadrant 4. So this equation will end up looking like 5 square root of 2 cosine of x minus 7 pi over 4. Now, there is a second equation that's possible. Find that equation now, without the use of a calculator. You should have found the second equation to be 5 root 2 cosine x plus pi over 4. Now transform this equation into a cosine x minus c form. So in this example, we end up having values that aren't special, so we need to find and use a reference angle, which we have learned how to do previously. But just in case you don't remember, here is where you find the reference angle. In the first quadrant, you find the reference angle, and to find the angle in the other quadrants, you have to use these formulas. Since our needed value lies in the second quadrant, we're going to have to subtract the reference angle from pi, and since we're using degrees, it will be 180. To find the reference angle, we would have to do the inverse tangent of 5 over 12, which gives us this value right here. And then we use this value to find our actual angle that we need by subtracting it from pi, or in this case, it's 180 degrees. So once we find this value, we can plug it into the equation, and previously we found that the amplitude is 13 by doing the square root of 5 squared plus 12 squared.
Alright, so we have this equation and we're going to solve for it. So the first thing we're going to do is we're going to transform the equation into the other one. So since this is 1 and this is negative square root of 3, we know that we're in the second quadrant. So I'm going to draw my triangle just so I can have it as a reference. Alright, so this will be negative square root of 3, this will be 1, and I know that that's 2. And here will be our angle. Okay, so what we're going to do is we're going to transform it. So 1 squared plus square root of 3 squared is equal to 4, and that is 2. So we know that for our new equation that a will be 2, and then we have cosine. So next thing we're going to do is we're going to find the transformation for the new equation. So to find c, or whatever you want to call it, we're going to do tangent opposite 1 over negative square root of 3 over adjacent, and we're going to find whatever that is equal to on the unit circle. So our answer will actually be 5 pi over 6. So we know that this is x minus 5 pi over 6. So that's our equation. But remember, we still have equals to 1, so now we got to solve it. So what I'm going to do is I'm going to divide both sides by 2. So we got cosine of x minus 5 pi over 6 is equal to 1/2. And I'm going to transform this so that x minus 5 pi over 6 is equal to theta. So cosine theta is equal to 1/2. Now I'm going to find a general solution for wherever this is true. So I have theta 1 is equal to pi over 3 plus 2 pi k. That's where cosine is equal to 1/2. And we also have that cosine is equal to 1/2 at negative pi over 3 plus 2 pi k. Originally it would have been 5 pi over 3. But I changed it to negative pi over 3 because it would have been too big. So I'm just going to use that to make it easier. Alright, so now I need to convert it back into x. So x minus 5 pi over 6 is equal to pi over 3 plus 2 pi k. And I need to do this for both equations. So x will be pi over 3 plus 5 pi over 6 will actually equal 7 pi over 6 plus 2 pi k. So here's one of our general solutions. And then x minus 5 pi over 6 is equal to negative pi over 3 plus 2 pi k. So negative pi over 3 plus 5 pi over 6 is x equal to 3 pi over 6, which is also 1/2, So I'll erase this and put pi over 2 plus 2 pi k. And that's our second general solution. Alright, so from these two general solutions, and from our domain restrictions of 0 less than or equal to x less than 2 pi, we can find our final answers. So in this equation, we have x is equal to 7 pi over 6. And if we try to add 2 pi k, it'll be over our domain restriction, so that's the only answer we can get from this equation. Now from this equation, one of our answers will be pi over 2, but if I try to add 2 pi, I again will go over the domain restriction, so that will also be my only answer from this equation. So these are our final answers.
Now try to solve this equation using this domain restriction. So you should get an answer of pi over 4, and you get that by first figuring out what quadrant you're going to get your answer in. This one, because both sine and cosine are positive, this is going to be in the first quadrant. And I have a triangle over here, and both sides are 1, so you get a hypotenuse of square root of 2, which equals your amplitude of your equation. Then you have the tangent of the sine over the cosine, which equals 1, and that is pi over 4, so that's how you get your c value. And all of that is equal to square root of 2. So I divide both sides by the square root of 2, and I'm left with cosine of theta minus pi over 4 equals 1. Now I substitute this for x, and so I have cosine of x equals 1. And cosine is 1 at 0, and then to get the general solutions, you add 2 pi k. So you have x equals 0 plus 2 pi k. Then I substituted this back in for x. So I have theta minus pi over 4 equals 2 pi k, which equals theta equals pi over 4 plus 2 pi k. And because you can't add 2 pi k to pi over 4 because you'll go over this, you only have the answer of pi over 4. Now try to solve this equation over the same given interval. So after you solve, you should get answers of 0 and 2 pi over 3. I solved this by first constructing a triangle with root 3 as the sine and 1 as your cosine, and you should get a value of 2 for your amplitude. And then for your angle, I did tangent of root 3 equals pi over 3, and that gives you this. And then I divided both sides by 2, which gave me cosine of theta minus pi over 3 equals 1/2. Then I substituted this for x, and cosine equals 1/2 at pi over 3 and negative pi over 3, or 5 pi over 3, but 5 pi over 3 and negative pi over 3 are coterminal. I set whatever x was equal to the answers I got and solved for theta. So for the general solutions, I got theta equals 2 pi over 3 plus 2 pi k, and theta equals 0 plus 2 pi k. And since you can't add 2 pi k to either of these because it goes outside of your given interval, you're left with these two answers.
So this has been Svetlana, Gabby, and Hannah teaching you about linear combination identities. A good rule to remember is a cosine x plus b sine x is equal to c cosine x minus d, where c is equal to the square root of a squared plus b squared, and cosine d is equal to a over c, and sine d is equal to b over c, and tangent d is equal to b over a.
And remember, you can always use your calculator to check your answers.
Also make sure to check what quadrant you're in and what domain restriction you were given.